The RTD, on the other hand, is just a standard 3-conductor copper wire, and there's less trouble, less problems with having that located a long distance from your control system. In either case, though, if you're running over, say, 250, maybe 300 feet between the temperature sensor and your control system, you may want to consider adding a transmitter locally right at the temperature measurement point. And that way you get a much more robust signal going back to your control system.
We see transmitters being placed on thermocouples and RTDs a lot. But an interesting note is you really should get that transmitter away from the head of the RTD or the thermocouple. Get it away from that heat source if you can. The transmitter is an electronic device. So once removed from the heat source, it's extremely helpful and it's handy. You can recalibrate it. It's worth the investment.
Right. Most of those have about an 80 or 85 degree C maximum ambient temperature limit on them.
Yeah.
And it can affect accuracy if you're at anything other than room temperature.
Hey guys, we have a question on the chat. Somebody's asking to repeat again how vibrations affect RTDs and why they're limited to 30 Gs.
Oh, okay, sure. What happens with an RTD in high vibration, especially the wire wound, is that the platinum wire starts to move a little bit within its potting material, and it can work harden and cause the resistance characteristics of it to change. And it's a very slight change, but it might be only a few hundredths of an ohm, but that translates into a higher temperature change reading. And the thin films are going to be more resistant to vibration just because of the way they're constructed. That thin layer of platinum that's on that ceramic substrate, it's bonded to it fairly well, and it can't really move around very much. And the key with getting very vibration-resistant sensor package with a thin film has to do with how the thin film is supported inside the temperature probe. And there's several different potting techniques and supporting techniques to do that. And when it's done correctly, they can be extremely durable.
Now, if you take a standard RTD and place it in a thermal well, the vibration, and place that inside, let's say, a water line, that water line vibration is not going to be an issue. Would you agree? We're talking something that's got some real high vibration. That's going to be a real issue here.
To a certain extent, having, putting it in a thermal well and, beefing it up, adding more mass to it, more weight, tends to dampen up some of the vibration and things. And, that's certainly, if you do have that type of an application where it is a lot of vibration, having a robust thermal well to put the sensor in is definitely a good thing to do.
Ah, very good. Good point. Here's some cost considerations. And, again, when your temperature demands a thermocouple, all well and good, that's your only choice. But I see, it seems a lot of the time, people will call up and say, look, I just need something down and dirty. I just got to get this thing going. And opt for a thermocouple when there should be other considerations. People are cutting corners. You're trying to save money. I understand that. But when you take a thermocouple and you add the thermocouple run wire back to it and the longevity of the thermocouple, I guess what I'm saying is you really need to keep an open mind before you choose a thermocouple over an RTD if it's just coming down to cost.
Yeah, it's really about the total life cycle cost of that temperature measurement point. And most of the time, the RTD is going to be the best choice. And again, you need to start out by looking at that temperature range first. And if an RTD fits in your temperature range, that's really the one you need to look at.
My experience out in the field has been, if you want accuracy, and you want that accuracy to last for a period of time, I would agree with you. The only time, again, I would go with that thermocouple is when it's beyond the temperature range of the RTD.
Some typical applications that we run across, thermocouples, I mentioned exhaust gas on like a diesel engine, for example. And Harold, you can talk about boiler rooms for sure. And injection molding machines. Sometimes they're used a lot for bearing temperature, although RTDs are used there also. And then some of the oil refinery temperature points are beyond what an RTD can handle, so they're used very commonly there. And places where temperature is really critical and accuracy is of the utmost importance, pharmaceuticals. Huge place in the area for RTD usage. Fuel custody transfer, where oil companies are transferring gasoline, for example, that might be in a underground storage tank, and they're pumping it into a rail car that's sitting out in the sun, and it's 110 degrees. They need to know the very quick and accurate temperature of that fuel as it's coming out of the ground going into that tanker car, so that they don't overfill the tanker car. That fuel is going to expand as it gets hot, and it can be very easy to actually be not only overfilling the tanker, but not charging the correct amount for what they're putting in there. And I don't know, Harold, do you have anything to add here? Maybe talk about the...
Yeah, in fact, I do. And I was thinking, these different applications, you think of the standard, maybe a direct immersion into a process with a temperature probe or a thermal well, but you may have a need for a non-intrusive application where you can't have anything touching the process. Well, we can do that. You may have a need for a sanitary tri-clamp type application. Well, we can do that too. You may have a need for a temperature sensor, but you can't, it's just not giving you enough room to actually stick a probe down into a process. Well, we've got something to do that as well. So if you have an application out there that you think it may be a little difficult, run it by us. Let us take a look at it. It may surprise you what we have in our bag of tricks. And here we have another cheat sheet, if you will. If you can print this off, this is a good one. Again, what it does do is it tells you what I can do with a thermocouple, what I can do with wire wound, what I can do with thin film. That's a good one to save. Anything you'd like to add to it, Bill?
Well, just there you can see where, the thin film, we've got that and a thermocouple for the, the high vibration shock kinds of things, and where you need the best accuracy, the wire wound is going to be your best choice.
Very good.
And, the one thing that I've seen is like every application is different. Even if it's the same industry, same kinds of process, everybody has their system set up just a little bit differently, and you need to look at that application and look at all the specifics of the installation of the sensor, the choice whether it's an RTD or a thermocouple, and make sure that the installation methods are correct to get you the best, most accurate temperature measurement. Again, I like to always start with an RTD. Look at the temperature range first. If it fits within that temperature range, great. And then look at the vibration, mechanical shock that may be going on, and see if the RTD fits within those parameters. If it does, great, that's the right choice. If it doesn't, then move to a thermocouple as a solution.
And if you do use a thermocouple, don't just install it and forget about it. It has to be maintained. That's probably true with an RTD. Just make sure everything's still in calibration. It doesn't hurt.
Right.